Okay, so we've got a real high-tech detective story for you today. The crime scene? It's a massive sugarcane field. The culprit? It's practically microscopic. And the detective? Well, that's our eye in the sky. So just picture this for a second. You're a farmer. You've got this huge expanse of sugarcane, a crop the whole world relies on. But hidden somewhere in that sea of green, there's this tiny little pest that's just silently wrecking your plants. How in the world do you find it before it's too late?
The answer, as it turns out, isn't about looking harder with our own eyes. It's actually about using some incredible technology to see what's completely invisible to us. It's about seeing the plant's secret signals that it's in trouble. All right, so first, let's meet the villain of our story. This is the pink mealybug. It has a fancy scientific name, Sacchariccoccus saccharae, but all you need to know is that while it may be small, the damage it causes is absolutely enormous. And believe me, this isn't just some minor annoyance. This bug goes right for the sugarcane, stunting its growth and making it weigh less. But here's the real kicker. It lowers the sucrose content. That's the sugar we're actually trying to get. On top of that, it covers the plant in the sticky waste product called honeydew, which messes up the quality. It all adds up to a huge financial hit for farmers.
So how did farmers used to deal with this? Well, honestly, it was a lot like trying to find a needle in a haystack. The old way is pretty much what you'd guess. People literally walking through these massive fields, checking plants one by one by one. I mean, it's incredibly slow, it costs a ton of money and labor, and here's the worst part. By the time you find a serious problem, the damage is already done. It's just not a winning strategy.
And this is where our high-tech detective finally enters the scene. We're talking about the drone, or as the scientists call it, a remotely piloted aircraft, an RPA.
So here's the drone's secret weapon. It's called multispectral imaging. The easiest way to think about it is this. Our eyes see visible light, right? Red, green, blue. But this camera sees so much more. It can capture light frequencies that we can't see, like near infrared. And here's the cool part. Plants that are stressed out or sick reflect that light differently than healthy plants. So the drone isn't looking for the bug, it's looking for the plant's secret cry for help.
So to see if this whole idea could actually work in the real world, a team of researchers in Brazil, which is a huge player in the sugarcane game, set up this really fantastic experiment. Here was the game plan. First, they flew their drone over the field to get that special multispectral data. At the very same time, they had a team on the ground doing it the hard way, literally counting bugs on the plants. Then they split the plants into two groups. Low infestation if it had less than 20 bugs, and high infestation if it had more. The final, crucial step was to see if the drone's invisible data actually lined up with what was happening on the ground. Now, the drone really has two main tools for this job, two ways of analyzing that light. Let's think of them as two different kinds of detectives. On one hand, you have NDRE. Let's call this one the Scout. The Scout is super sensitive. It uses this thing called the red edge light band, and it can spot the absolute earliest signs of plant stress. On the other hand, you have NDVI, the Assessor. The Assessor is more of a big picture detective. It measures the overall health and vigor of the plants. So you've got one looking for the first hint of trouble, and another measuring the full scale of the damage. So, you've got your two detectives on the case. What did they find? This is where it all comes together. The researchers basically said it all right here. They found that the Scout, NDRE, was amazing at finding the low levels of infestation, the early warnings. But the Assessor, NDVI, that one was the real pro at finding the areas with severe infestations, where things were already pretty bad. And the numbers really tell the story. For those early low-level problems, NDRE, our Scout, was over 73% accurate. That is fantastic for an early warning system. But when the infestation got really bad, its accuracy just plummeted to below 45%. It basically gets overwhelmed by all the noise. But then you look at NDVI, our Assessor. It's the complete opposite story. It's not great at spotting those little early problems. But when you need to identify the really hard-hit areas, it's over 80% accurate. It's the one you call when you need to confirm just how bad the damage is. So what does this all mean? Well, the big takeaway is this. It's not a competition. It's not about which one is better. They're a team. You absolutely need both. You need the Scout to find the first signs of trouble, and you need the Assessor to tell you exactly where the biggest fires are burning. And look, this is way more than just a cool science experiment. This kind of insight could completely revolutionize how we do farming.
leading to a much smarter and, honestly, a sweeter future.
So let's walk through how this would actually work on a farm. A drone flies over the field using both of its detective tools, NDRE and NDVI. All that data gets crunched into a super precise infestation map. The farmer can then just look at this map and see the exact problem hotspots. And instead of spraying the entire field with pesticides, they can apply treatment only to those specific spots that need it.
The benefits here are just huge. I mean, we're talking about a move away from expensive, wasteful blanket spraying. That means less pesticide in the environment, which is a massive win. It lets farmers make decisions way faster and more efficiently. It's all part of a bigger move toward more sustainable agriculture, which at the end of the day helps make our food supply that much more secure. You know, we started this whole story with a tiny bug in a giant field. But the solution, using technology to see these invisible signals all around us, it really makes you wonder, doesn't it? What other huge, hidden problems could we finally start to solve if we just found the right way to see them?